Alright. Are you taking pictures, Tyler? And I moved it on you, I'm sorry. Alright, we left off with our cliffhanger yesterday. We were looking at Pete and Aaron and their Jeep tours. Pete, he will do the tour if he's got 2 to 6 passengers. We found the expected value was 3.75, standard deviation 1.089. Erin also runs a similar company. She'll do the tour if she has 2 to 5 passengers. Her expected value is 3.1, standard deviation of 0.943. So what we're going to do is we're going to add the 2 variables together. And I had you guys do predictions on what you think the expected value of Pete and Aaron together is and the standard deviation is. Alex, excuse me, Alex predicted 6.85. He just added them. Maddie said it's going to be around 3 because they both have expected values around 3. And then nobody else was brave enough to give me a prediction. Anybody want to add a prediction? Go ahead. Sorry. Say it louder for me. 3.425. Did I say it wrong? 3.4. How can you? What was your thought on that?
So I added the 2 means and then I divided by 2.
Okay, so you found the average. Right. Thank you, Cheyenne. Anybody else want to add a prediction? What are you 2 ladies doing back there? Okay. All right. And then same thing, I asked for predictions on standard deviation. I didn't ask for variance, even though I say and variance. Michelle said close to 1, because they're both close to 1. Nate did 1.016. He added the 2 standard deviations together, divided by 2. Anybody want to add a prediction? All right. Well, now we're gonna figure out who's right, if any of you are right. So before we actually get into the math of doing it, we do have to talk about something. The only way we can determine probability for any value of t, remember t is defined as x plus y. The only way we can do that is if x and y are independent random variables. Now in chapter 5 we talked about independence, and that really boils down to whether one event has an effect on another event. So just as a reminder, the definition: if knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving Y alone and vice versa, then they're independent random variables. So X happening has no effect on the probability of Y happening. Y happening has no effect on the probability of X happening. That is the same definition of independence that we had in chapter 5. In math, we often assume independence when it looks like they're unrelated to one another. I will say that is like one of the worst things that we do in statistics is we tend to assume independence. You really should ask yourself, does it seem reasonable that they're independent? This situation, we're going to assume it. but I'm just gonna say, to make it sound even more independent, they work on like different parts of the country. Okay, so I don't know. I hear Jeep tour and I think of Hawaii. I've never been on a Jeep tour in Hawaii. I don't know why my brain thinks Hawaii. I don't know where you would take a Jeep tour to. But, so let's say one of them's on the island of Oahu and the other one's on the island of Hawaii. That way their business has no effect on the other one's business, so we can assume independence. So that allows us to do some math, which we're going to do back here. So we're going to put some data in this table. We're going to put that data into our calculators, and then we're going to find our mean, expected value, and standard deviation. So the first two columns, that is peaked. So X sub I represents all the values of the passengers Pete has. So he's going to take passengers as long as he has 2 through 6. So notice that I have the value 2 multiple times, 3 multiple times, 4, 5, and 6. The probability, if we flip back and forth, for Pete, taking 2 passengers was 0.15, 3 was 0.254, okay? I just put those. So 2 had a probability of 0.15, 3 had a probability of 0.25. So I just put the number of passengers and their probabilities next to each other. So those first 2 columns represent Pete. The next 2 columns represent Erin and her business. Erin would take 2 through 5 passengers with these probabilities. I just listed them. 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Because what we're going to do is we're going to end up adding the number of passengers for Pete and Erin together. And because they're independent variables, from chapter 5 we know independent probabilities can be multiplied. So notice I filled in the first few columns over here. So T is defined as X plus Y. So X, Pete has 2 passengers, Erin has 2. 2 plus 2 is 4. So I filled in the number of passengers when we look at the 2 companies together. Pete has 2, Erin has 3, so that's 5 passengers total. Pete has 2, Erin has 4, so that's 6. Pete has 2, Erin has 5, that's 7. You're going to fill in the rest of the number of passengers. The last column here represents the probabilities for those number of passengers. So Pete having 2 passengers has probability of 0.15. Erin having 2 passengers has probability of 0.3. They're independent, so I can multiply the probabilities. So the probability of 4 passengers is 0.045. I did the same thing for 5 passengers, 0.15 times 4. So I want you guys to finish filling in those last 2 columns for me, please.
I was gonna leave and then I was like, whew. I don't know, like, took off my jacket.
I thought he at first was letting somebody in. I was like, is my door locked? Sorry. It's not small. I can read. It's neat. I can read, I don't know, I can read words from here. Yours I had to get closer to. The masks are making me feel old too, because I have to ask kids to repeat things, and I don't have that thing.
You say that.
Hey. I don't have bad hearing.
It's okay, we all get it.
Which color?
Both of them. Yeah, seriously. That was not very nice, Alex. It's okay.
I just put the class.
I'm not that involved. I have a little evil streak in me.
You know where you're probably like the nicest teachers and teachers. Like when it comes to like understanding students and stuff like that.
Well, I think so. We do have kids. Right.
I got a little distracted.
Right?
And I have told him
I have better than
Wait,
you.
you have 20?
just a little bit.
I got art class in freshman year, so it's like.
You got what?
So
Take care of
something.
Oh. Why would you do that?
I was blind on Christmas. I thought that was actually excited to talk to my eyes since it was testing.
This year?
Yeah, but I don't. Like my eyes were spotted like so weird.
Maddie?
Last year.
If you decide to just keep
No,
that.
I do that
no.
too.
Okay, actually, I don't know what happened. Like I didn't realize it was like a flashlight or something. Didn't freaking know why.
I do that all the time too.
I got it.
Who doesn't do that?
Hey, show me how to shave me that.
Thanks, Molly. All right, so she filled in the rest of the columns for us. Now what we're gonna do is we have all the different possibilities for the number of passengers for both Keat and Erin, all the different probabilities. So we're gonna put those two into our list so we can find our expected value and our standard deviation, right? So I would say put this one in list 1 and this one in list 2. And then you guys should hopefully remember how to get your expected value and standard deviation. In the middle over here, I do have a note about variance. I will talk about that, but you don't have to worry about filling that in because that's not one of the things the calculator gives you. And don't forget to put the first 4 entries that I did for you in the calculator.
I love track.
So I told you guys you didn't have to fill that one in, but Anna's going to tell you how she got that number, because it is correct.
You square that, the standard deviation in the calculator. Just square it.
Thank you, ma'am. So the middle one is variance. Remember the relationship between variance and standard deviation is standard deviation is the square root of variance, or variance is standard deviation squared. So the calculator gives you standard deviation, so she just squared it to get that number up here. So our expected value, the mean, is 6.85, which was Alex's prediction, which we just take our two expected values and add them together. So the mean of t, I'm going to say expected value of t, came from just taking the expected value of x plus the expected value of y. And just as a reminder, that one's the expected value of x and that one's expected value of y. Don't you love that we have so many different notations to mean the same thing?
Yeah, I got anxious.
I really don't know why we do that in math. We just decide, oh, we got you guys used to the word mean, now we're going to call it something else. And come up with a new notation because we gave it a new name. I would say that's my least favorite thing about this. So, standard deviation, I mean, I suppose I could give this to Michelle, right? She said 1 or close to 1. Although Nate was closer, you both were kind of there. You were both close to 1, and it's about 1.5. It's 1.44. Here, variance, which Hannah reminded us is just the standard deviation squared. I didn't have you find variance of Pete's Jeep Tours, but here it is. I found it for you. And the variance of Aaron's Jeep Tours or Adventures, Aaron's Adventures. What do you guys notice about these two numbers and that number? Say it a little louder for me. Yeah, so we can just add the variances to get the variance of t. So the variance of t, so sigma sub t squared comes from sigma sub x squared plus sigma sub y squared. Variance of t is the variance of x plus the variance of y. Standard deviation is the square root of that. So our standard deviation of t comes from the square root of the variances being added. Unfortunately, standard deviation cannot just be the standard deviation of x plus the standard deviation of y. Doesn't work. It would be nice if it was nice and simple like the expected values are, but it's not. So you can't just add your standard deviations to get the new standard deviation. So down below I have some generalizations. Can I move it up? Alright, so Pete had an expected value of 3.75. Aaron had an expected value of 3.1. So their average is 6.85 passengers per trip. So when we generalize that, if we're taking two random variables and adding them together, then the expected value for the sum comes from adding their expected values together. when we add two random variables, we can add their variances, but we cannot add their standard deviations. Now, most of the time the question is going to be, here's two random variables, here's their expected values, their standard deviations, and then I'm going to ask you to find the sum and find the mean and the standard deviation. The means you can just add. And I guess I should say expected values. If I ask you to find the standard deviation of two random variables added together, you have to find their variances, so square their standard deviations, add them together, and then square root. So there's a few more steps. So in your book, this is the formula they would give you. That is for variance because it's sigma squared. If you want to find the standard deviation of t, you do the square root of the variances added together.
That's for variation.
Standard deviation. This one is standard deviation, that one's variance. Is that what you were asking, Hannah? So you might want to make a note. Let's go with this color. You cannot add standard deviations. You must add their variances. Am I down below the screen? Thank you. That's really what that box is summarizing. And then of course, we don't always want to add two random variables. We might want to subtract them. So on the back, I have some generalizations about if we subtract variables. Can I flip to that? There you go. So this time, if we have random variables x and y still, we're going to define d to be x minus y. Expected value, nice and simple. You just take your expected value of x minus the expected value of y. The one thing to pay close attention to is the order of subtraction. And this is where I tend to see the most mistakes. X minus y is very different than y minus x. So you have to pay attention to which variable they tell you to subtract from the other. Order of subtraction is important. Then when it comes to finding standard deviation, if we're working with x and y, we define d to be x minus y. To find our variance, it's the same. You still add. You don't ever subtract variances. So even though finding standard deviation might have a few more steps, you have to square the standard deviations, add them together, square root them. No matter whether you're adding two variables or subtracting them, it's the same steps. Maddie doesn't like that, sorry. So the standard deviation of D would still be the square root of the variance of X plus the variance of Y. And now we're going to look at the exit task, which is a difference problem, and we're going to do it together. Can I move it up? All right, so down below, excuse me, on the left it says X represents the number of cars sold for Mr. Wilcox for January. The values of X are 0, 1, 2, and 3. Probability 0.3, 0.4, 0.2, 0.1 respectively. Y represents the number of cars sold for Mr. Wilcox for February. The values of Y are 3 and 4 only, with a probability of 0.6 and 0.4 respectively. We're going to assume X and Y are independent. So that means we can add or subtract these random variables. Most of the time, the question will say something like assume independence. If it doesn't say it, for now, we're going to assume. In not chapter 7, chapter 8, I'll teach you the criteria for checking independence. But for now, it'll either say it or you can assume it. So we're going to let D be the difference in the number of cars sold between January and February. So we're going to do X minus Y. And we're going to create our probability distribution. So we're going to find all of the different possible values of D and then their probabilities. Now, I'm going to put a little extra note at the top. So I'm making an extra line. And hopefully that'll help you guys see how I got my values of D. So we're going to, excuse me, take X minus Y. So first value for X is 0 minus first value of Y, which is 3. 0 minus 3 is negative 3. So the note I'm going to put up there is that it came from 0 minus 3. Like I said, you don't have to put the note, but I'm going to put it there just so you guys see how I'm doing it. Then I'm going to do 0 minus 4, which gives me negative 4. Then I have 1 minus 3.
Why wouldn't you do it the other way? Like
You- 4 minus 0.
like you know, like how you're doing like 0 minus 3, 0 minus 4.
Because it tells me to do X minus Y. No, that's not a bad at all. That's why up here I said the order of subtraction is important. Because if I did it the other way, I'd get 4 and 3. And then when I do my formula for expected value, I have positives being multiplied by probabilities. And so I'd get a higher expected value than it actually is. So that was not a bad question at all, Sam. Okay, that's why somewhere in the question it's going to tell you the order, and order is extremely important for subtracting. With adding, it doesn't matter because adding is commutative. Subtraction is not. All right, so next one, 1 minus 3, which is negative 2. And then 1 minus 4, which is negative 3. Then I have 2 minus 3, which gives me negative 1. 2 minus 4, negative 2. And then we have 3 minus 3, which is 0. Oops. And 3 minus 4, which is negative 1. Yes.
How come we have to go like every one, like the 0 is times that twice, and like which number is times is multiplying by like why wouldn't you do like 0 times 3 and 1 times 4?
Because I want to make sure I get all possible values. I don't know if this is going to make sense. But let's say I had ham, turkey, salami, and pastrami. And I had cheddar and Swiss cheese. And I said, what are all the types of sandwiches I could make? I would have to make sure each type of meat is offered with each type of cheese. Does that make sense?
Yeah, I was just confused.
I'm glad that sandwich thing worked. I was like, I'm either going to make sense or I'm going to sound really crazy with sandwiches here. Sorry. All right, so then for our probabilities, so I did 0 minus 3, so I'm going to take 0.3 times 0.6, which is 0.18, right? I get a little less confident with decimals, 0.18. And then 0 and 4, so 0.3 times 0.4, that'd be 0.12. 1 and 3, so 0.4 times 0.6, which is 0.24. Do you guys want me to write below how I'm getting those probabilities? I am just multiplying them. But since it's the first time that we're doing a difference problem, I thought, kind of like how I showed where I got my values, it might help to see where I got my probabilities. So this came times 0.3 times 0.6. This one's 0.3 times 0.4. This one's 0.4 times 0.6. And then I would have 0.4 times 0.4, which is 0.16. And then 2 is 0.2 times 0.6, so 0.12. 0.2 times 0.4, that's 0.08, right? Yeah. And then 3 is 0.1 times 0.6, so that'd be 0.06. And then 0.1 times 0.4, 0.04. Any questions before we move on to finding things? Yeah.
Do you have to add them all, make sure it adds to them, or do you just?
You can. I mean, they should add to 1. But am I going to ask you to? No. I may give you, like on a multiple choice question, I may give you a distribution and say, is it legitimate? And then you would check and make sure they add the 1. But on this, no. We could though, make sure I did it right. That's 30, 54, 60, 70, 82, 91. I got 1. So then we're going to find the mean, the variance, and the standard deviation. The calculator gives you these two, and as Anna reminded us, standard deviation, if we square it, will give us our variance. So in your calculator, you're going to make 2 lists. Oh man, pink makes those orange writing disappear. Sorry. You're going to put the values of D in list 1, and then all the probabilities in list 2, or 3 and 4, if you want to keep your other stuff. I apologize that those first 2 numbers disappeared on us. I didn't even think pink over orange wouldn't allow it to show through. Find the mean, variance, and standard deviation. Please. To find variance, you have to do an extra step. But the calculator gives you the mean and standard deviation. I am starting.
Is that more accurate?
Yes, much more accurate now. Thanks, Ronnie. Yeah, you can go 1.063. But she went to 1.06. But you can go to the 3.
I thought standard deviation was only like it was supposed to be 3 decimals.
Yeah, that's enough. Okay, 2, 3. I'm not taking.
You don't get to.
You know what? I feel like we both judge each other. Alright, walking around, most of you have this. Mean is negative 2.3. Standard deviation, you get 1.063. And then to find your variance, you would do 1.063 squared. Now, some of you did round this to like 1.06, and you get 1.12 for the variance, which is fine. Do not round to 1.1. Any questions? No? All right. Thank you, Shelley, for sharing those, by the way. So tonight you're going to finish, if you didn't finish, if you did the first 2, like I said, you could after yesterday. If you didn't, make sure you do all 5 of them tonight. And